Alright, so today we're going to be doing 10.5, which is conditional probability. So if you were here yesterday, you already have these notes. It's on the back of the 10.4 assignment. So we're going to discuss what are called contingency or two-way frequency tables. So you do learn about this in Algebra 1. It may look familiar to you. It's basically a table of data that compares different categories together. And then two important vocabulary terms that deal with this are called joint frequencies and marginal frequencies. So how do you differentiate? Well, marginal are the ones that make up the anything in the total category, and joint are anything in the middle. So the way I always tell students to remember this is when you think about a piece of paper, okay, like a loose leaf paper, what do we call those edges of the paper? Then we call it the margins. Have you ever heard that? The margins of the paper?
Oh yeah.
So the margins of the paper are the same as the margins of a frequency table. They're on the outer edge, okay? So that's a way to remember the difference between the two. So before we get started, we're just going to talk a little bit about some probability just to kind of get you back into the mindset of how this works. So we have 2 blue and 3 red marbles. What are the chances of drawing a blue and then a red marble? So then we know is multiplication. So what's the chance of drawing a blue marble in this case?
It'll be 2 out of 5.
Good. Times then a red, meaning you're doing it
3 out of 5.
consecutively after.
3 out of 4.
3 out of 4. So remember, with then, we don't replace. If they use the word then, there's no replacement. Okay, we have to adjust our denominator. So is everybody understanding why it's 3 out of 4? Because we took 1 out. So if we do that multiplication, we get 6 out of 20.
Which is 3 out of 10, which is
Very good.
30%.
30%. So on some of these problems, just for the sake of time, I won't be converting all of them to percents. So just remember how to convert to percents when needed, when asked, okay? What are the chance of drawing 2 blue marbles? So what is the chance of drawing the first marble as blue?
2 out of 5.
2 out of 5.
Times 1 out of 4.
Times 1 out of 4. So remember, the numerator on this one is going to change because we took one of the marbles out that is blue. So there's only 1 blue marble left in the bag out of the 4 marbles that are left, which gives you 2 out of 20,
1 over 10,
which is 10%. All right, so you have a better chance of drawing blue and then red than blue then blue. Okay. So next, we're going to talk about conditional probabilities with contingency tables. So when you have a contingency or a two-way frequency table, these words will be used interchangeably. You always want to find the totals. Okay? These are what the marginal frequencies are going to look like. They're always going to be totals. So in that box, you're going to fill in the word total. Now to find each total, you basically just add downward and then add across. So if I add all these values going downward, I get this number. If I add all of these numbers, I get this. Okay, I'll just explain how. I know you all know how to do addition, so I won't explain all that. So we add across. I'm adding across. These are adding across. And then the final total, the total is really what I call it. You can do it 2 ways. You can either add these together or add these 3 together. Now, when you do either one of those, they should come out to be the same number. So that's also a perfect opportunity to check your work. Make sure these 2 add up to the same thing as these 3 add up to verify that all the math has been done correctly. All right, because it's easy to make a mistake with these kind of addition problems, and you need to get in the habit of checking your work with these kind of problems so that you don't make silly mistakes. Okay, because I know it's frustrating when you're on a test and you make a silly mistake, but they do happen, so try to prevent them as much as possible. All right, so the first problem just wants to know, whenever they don't give you a given, like they just specify probability of something, you always use the complete total, okay? So what is the probability of choosing a female?
That would be 4,328 out of 17,470.
Females would be...
9,933 over
You got it?
7,472.
Yes. So those are all the females in the school out of the total number of people. All right. Now here's where we get into something a little different. This slash indicates what we call a given, okay? A given. And when you do a probability with a given, how this reads is the probability that the chosen person is female given they are a grad student. So how the given works is the given always determines your denominator, okay? Determines denominator. I didn't mean to use the eraser, sorry, but I'm just trying to specify that given determines the denominator. You don't have to write these notes if you don't want to, it's your choice, but I'm just trying to explain to you. So this determines your denominator. So your denominator is based on graduate school. How many people in total went to graduate school here?
32,000.
Good, and how many of those people who went to graduate school were female?
1954.
Good. So you see how the total changes if we're looking at a given. Sometimes with these contingency tables, we only want to look at a smaller sample of people. We might only want to look at 2-year college students. We might only want to look at female, male. So be aware that the denominator can change. We're not always looking at the complete total. Okay, that's how we get different probabilities in different scenarios. So probability that you are a 2-year college student given that you are male. So male is my denominator. How many total males are there?
539.
And of those males, how many went to a 2-year college?
1,866.
Good. This problem is the probability that you are male given you went to a 2-year college. How many people in general went to a 2-year college?
4,800.
1,800. Oh, sorry, 4,000.
And of those total 2-year college students, how many were male? Now you're what you said, 1,000.
Yeah, 1,866.
866. So you see how C and D are different? They're comparing the group out of a different pool of people. So they're both looking at 2-year college students who are males, but one of them is comparing them to total 2-year college students, and one of them comparing them to total males. Do you see the difference there? Okay. So, like I said, I can ask you this question and ask for the percentage as well, so please make sure you're going to be converting. I'm not going to be converting all these for you, so make sure you know how to do the conversions. We've been practicing it for a while, so I think you guys have it down, hopefully. All right. Hopefully. So now we're going to be comparing different materials and whether they be recycled or non-recycled. So we have our totals. And I did all the math ahead of time, so we don't have to spend time adding all this up in the calculator. If you want to, yeah, that's fine. This is most of these tables will be for your reference. So unless you're dealing with a situation where you have to fill this in like a formal setting for a test, that's fine. So everybody understand what I'm doing here, right? Totaling across. So like I said, there's a, no pun intended, in the margins, there's a large margin for error because it's just so easy to accidentally type like a 2 instead of a 3. So always at the end verify that these total numbers add up to these total just to make sure that you added everything correctly. Okay? So once you have listed all these values, now we're going to look at the problems associated with them. What is the probability that the material is paper given it is recycled? So, given it is recycled, we're looking only at recycled materials. What amount of recycled material do we have in total?
79.4.
And of that recycled material, what amount of it is paper?
45.2.
Very good. Now sometimes the question is not going to come out and say the word given. You have to read the context clues using your English reading skills, right? What is the probability that a sample of paper is recycled? So do we care about the total number of recycled items in this question?
No.
No.
We only care about looking at paper. Total, yes, good. So we're looking at paper, and of these samples of paper, we're looking at what amount of that paper is recycled. So our denominator is going to be the total amount of paper, and then we want to look specifically at recycled paper. So the difference between A and B, A is looking at the total number of recycled material and what amount of that recycled material is paper. B is looking at the total number of paper and looking at what amount of that paper is recycled. Okay, you see the difference between those two scenarios. Okay. This one here, we're going to be looking at bill payments, male, female versus online and by mail. You're going to have your totals. These ones are easy to do in your head, which is nice. And this one's easy to verify. 20 plus 30 is 50, but 36 plus 14 is also 50. So you see how you can verify that math pretty easily on this one. So what is the probability that a customer pays a bill online given that customer is male? So we're looking at the total number of,
Male customers.
which is
20.
20. And of that, we're looking at ones that pay,
Online was
Online,
12.
which is
which reduces to
60%.
60% or 3 over 5. Good. What is the probability that bills paid online are paid by females? So do we care about the by mail bills right now?
No.
no.
We're only looking at the total of bills paid,
Online by females.
and of that group we're looking at female.
24 out of 30. Oh,
4 out of 36.
24.
36, which is 2 out of 3, which is 66.7%. So something like 2 out of 3, the thirds we usually leave as a fraction as opposed to a percentage because they always have that repeating number. Okay. Any questions about this particular topic? Okay. We're going to do a few more problems. Now we're going to look at these things called tree diagrams in probability. So a tree diagram is a way in statistics of visual representation of different forms of probability. Now these can be, we're going to look at a very simple example of one, and then we're going to look at how this can be used in a more complex way. So a school system surveyed adults who attended high school 10 years ago. That's me. I attended high school 10 years ago. Exactly, actually. 85% of adults surveyed graduated from high school. 90% of the graduates were happy with their present job, and 60% of the non-graduates were happy with their present job. So when you set up a tree diagram, you cannot assume they give you the information in the proper order. You have to think of which thing happened first chronologically. Chronologically, are we going to look at happy with their job or whether or not they graduated from high school?
Graduated from high school.
Graduated from high school. Not to say you can't have a job in high school, but it looks like we're talking about postgraduate, after high school jobs,
Or
right?
dropped out.
Yes, exactly. So 85%, 0.85 graduated, correct? Which means, incidentally, how many did not graduate? What
15%.
15%. So you always have to be able to find that on your own. Okay. You just want to put whatever abbreviation there that's going to denote to you what you're representing that number by. Of the people who graduated, what amount were happy with their job?
90%.
So 0.9 were happy. I'm just going to put H for happy because of lack of space. Which means what percent were not happy?
10%.
0.1 were unhappy. Of the non-graduates, what percent were happy?
60%.
Which means what percent were unhappy?
40%.
Good. All right. So this question is very simple, and I'm going to explain to you how to read these questions and differentiate what kind of math they're asking you to do. So the question says, what is the probability that a person who graduated, okay? See how they specify which type of person they want you to look at. If they just said person, the math's going to be a little different. So if they give you a category to look at, the math's more simple. A person who graduated from high school is happy with their present job. So we are already going to be looking at the person who graduated. So when they give you this, you get to kind of fast track. Think of the fast track line at Universal. This is what you get to do when they specify. So we get to fast track through people who graduated because we already were given that information. Now of that group, what percentage were happy?
90%.
So the answer is just 90%. So we already know, of the people who graduated, we already know what percent were happy. Once again, what is the probability that a person who did not graduate from high school is unhappy with their present job? So did they specify what kind of person we want to look at?
Person who did not graduate.
So we get to fast track, and then which path are we going to take?
40%.
40%. So these are the simple problems you can do with a tree. Now we're going to look at one that requires a little more steps, a few more steps. Nothing too complicated though. So you're going to notice the notes are finished. So what I want you to do is flip to the back and we're going to look at 3 and 4 together. Number 3 and 4 on your homework. Okay? So I'm going to be pulling up 3 and 4 on the homework right here. You're going to do the rest of the homework on your own. So the reason I wanted to do these is because they do require a little bit more thinking. Okay, so let's look at number 3. A football team has a 70% chance of winning when it doesn't snow, but only a 40% chance of winning when it snows. Suppose there is a 50% chance of snow. Determine the probability that the team will win. So, we're talking about snow versus no snow. Winning versus not winning. Which of these things is going to occur first?
Snow.
The snow. So see how the question is written in an out of order way? So the chance of snow versus no snow is 50-50. So we got the chance of snow. And then we have the chance of no snow. So does everybody see why those are even?
Yep.
Okay. So from here, if it snows, right? If it snows, what's the chance of winning?
40.
40 is a win, which means what's the chance of a loss?
60%.
Good. Now if it doesn't snow, what's the chance of winning?
0.7.
Good. And what's the chance of losing?
0.8.
Yeah. Okay. So it says, determine the probability that the team will win. There are 2 scenarios of which the team can win, correct? Based on what we know. They didn't specify in the question. The question is very simple. They just say probability that the team will win. Did they say the probability that the team will win if it snows? Did they say anything about the snowing? So we have to think of that as a separate entity. We have to think about it overall. So there's 2 scenarios that can happen. It snows 0.5 times the probability that they win. Or we're also okay with, remember, or is addition, or what can happen is it doesn't snow times the chance that the team wins. Okay? So that's going to give me 0.55 or 55% chance of winning. So if the question is less specific, you have to do more math, basically. All right? So I want you guys to try the second problem. But before you do, I want you to be very careful. This one specifies. This one keeps it general. See that? So you guys go ahead and fill this problem out. I'm going to put the answer up in about 3 minutes on the board. Okay, so go ahead and try it out, and then I'll put your answer up. Alright, so this is what I got. So make sure you understand the difference between, the subtle difference between the way the question is asked. Okay, it can be a little bit tricky. But I'll just go ahead and explain really quick. So in the first probability, they tell you to only look at female respondents. So that means you get to fast track. We only care about the female respondents. We don't need to deal with the probability of them being female because we're assuming that they are right off the bat. Within the realm of the female respondents, only 10% of them are left-handed. Simple as that. Now, as for question B, they just say respondent. They don't specify what type of respondent we're looking for. And then after they say respondent, any respondent, they want to know if you pick any random respondent out of the whole group if they happen to be a right-handed male. So in order to be a male, that's a 17% chance of happening, times then you have the chance of them being right-handed, which would be 11.4%. Does that make sense, the difference between the 2 scenarios? Perfect, perfect. All right, you guys have the rest of the period to finish up 1 and 2. Should be pretty easy to get your homework done this period.